a Kate y Kat con su charla de convertirse en un caballero oscuro.
Bueno, muchas gracias. Bienvenidos todos. Gracias por venir. Estamos muy agradecidas de poder dar esa charla. De hecho, representa la primera vez que nuestro equipo está presente en América Latina, entonces es un honor completo. Nuestra charla va a ser como medio inglés, medio español. Y bueno, ojalá que sea útil.
My name is Kat Self. I'm going to apologize now for the English portion of this presentation. Thank you for bearing with me. I started my career as a professional artist. That went so well, I became a glorified malware developer. And then now I get to work at MITRE ATT&CK. I'm actually the Mac OS lead and Linux lead for MITRE ATT&CK. So for those of you that have heard of that, all of your complaints for those two platforms are for me. And then I also used to work at Target, where I got my start in this career, where I started off as a software developer and moved to a red team. And then I actually moved to a threat hunting role, where I actually helped design their program.
Hola, me llamo Kate. Yo trabajo como analista de ciberinteligencia en MITRE. También yo tengo un blog que se llama Phishing for Answers. Está disponible en inglés, español. Yo llevo casi 10 años trabajando en asuntos latinoamericanos. Acá en MITRE yo me enfoco en grupos cibercriminales en la región. También yo he pasado mucho tiempo en Buenos Aires, por eso mi acento es bien porteño. Anteriormente yo trabajé como analista de inteligencia en Meta, también conocido como Facebook. Y bueno, mucho gusto. Gracias. Bueno, queríamos empezar la conversación sobre la diferencia entre una emulación de adversarios y una simulación de adversarios. ¿Qué es la diferencia entre esos dos conceptos y cómo puede ayudar una emulación de adversarios? ¿Cómo puede ayudar a defensores de redes cibernéticas? Entonces, vamos a considerar ese ejemplo que tenemos en la pantalla. Tenemos Batgirl, mujer murciélago, y Supergirl, supermujer. Realmente nos encantan los cómics, ¿no? Una emulación es considerar todo lo que hace Batgirl contra una víctima en la red, ¿no? Todas sus técnicas y recrearlas en un escenario, ¿no? Entonces, con una emulación no hay mucha flexibilidad. Tenemos que como reproducir exactamente lo que hace Batgirl, lo mejor que podamos. Por otro lado, una simulación de adversarios es considerar algunas cosas que hace Batgirl, otras acciones realizadas por Supergirl, aún otras técnicas utilizadas por otro adversario, mezclarlas y recrearlas. Entonces, con respecto a simulación, es más una aproximación de un adversario y es un poquito más sencillo. Pero es nuestra posición de que una emulación, emular a un adversario, da un conocimiento nuevo y trae una perspectiva única con respecto a lo que está pasando dentro de una red. Entonces, el enfoque de nuestra charla hoy es emulación.
Another way to put that is Supergirl kicks in the door, whereas Batgirl picks the lock. And in this case, we will pick the lock.
Ok, entonces, ¿qué es MITRE ATT&CK? ¿Qué es ATT&CK Evaluations, nuestro proyecto? ¿Alguien acá ya sabe de MITRE ATT&CK, la matriz? Ah, muchos, ok, me alegro. Para los demás, para que ustedes sepan, MITRE ATT&CK es una matriz de datos como sobre ataques específicos según lo que hemos observado en el mundo real, en el mundo cibernético, ¿no? Entonces sirve como una manera compartida de referirse a ataques específicos. Entonces para que diferentes equipos puedan comunicarse sobre el mismo comportamiento, ¿no? Entonces, para que, o sea, son equipos azules, equipos rojos, cazadores de amenaza, para que todas diferentes partes se puedan comunicar sobre el mismo tema. Attack Evaluations, nuestro proyecto, es informado por MITRE ATT&CK. Entonces, lo que hacemos es ejecutamos planes de emulación de adversario contra productos de ciberseguridad para probar sus defensas, ¿no? Entonces, el propósito de eso es exponer los puntos débiles dentro de esos productos y exponer como falta de detección. Entonces, estamos probando la capacidad de esos productos a detectar acciones maliciosas. Y después de cada emulación, nosotros publicamos todo nuestro código, nuestros recursos, nuestras herramientas en nuestro repositorio de Git. Para el proyecto, creemos que el proyecto se pertenece a cada usuario final, ¿no? Porque nuestro propósito, nuestra metodología hace que defensores mejoren sus redes.
Another note about that is it's their default configurations. So every vendor deploys their default configurations, and the goal is to elevate the industry by elevating what is their lowest tier that they offer to everybody else. And so that way, you all are getting to benefit from this. So our real goal when we're providing these techniques is to hit that bottom line, which we're really happy about after we hear feedback of what they put in for Turla. We were like, oh, you added that to your default config? Why, thank you.
Ok, bueno, esa imagen muestra nuestro proceso de crear, desarrollar y ejecutar una emulación. Esa representa nuestra metodología, nuestra como solución de colaborar entre diferentes equipos para lograr una emulación. Entonces, primero yo voy a hablar sobre el proceso de inteligencia, de seleccionar un adversario, de investigarlo y crear el plan. Y luego, Kat va a hablar sobre el proceso de desarrollo, cómo el equipo de desarrollo cómo transforma el plan en código, cómo ellos establecen herramientas, hacen troubleshooting y al final ejecutar el plan, ¿no? Y en preparación para la charla, nosotras creamos y desarrollamos un plan real de emulación y entonces al fin tenemos un pequeño video para demostrar nuestra emulación de un adversario. No sé, para demostrar cómo nos pasó. Ok, entonces, la primera etapa. Antes de pensar en adversarios posibles, la primera etapa es pensar y considerar los objetivos de la emulación. ¿Qué significa un buen villano para vos, para tus organizaciones, no? Como ya dijimos antes, una emulación de adversario trae una perspectiva única a la red. Y entonces la pregunta es, ¿qué conocimiento nuevo, qué perspectiva única están tratando de lograr, tratando de realizar a través de la emulación? Cuando logras decidir eso, puedes pensar en los villanos. En Attack Evaluations, el proceso de elegir un villano es muy colaborador, pero tenemos un criterio básico, ¿no? Entonces, nos preguntamos las siguientes preguntas. Primera, ¿hay reportes de CTI suficientes y recientes? Recientes quiere decir dentro de los últimos 2 años. Segunda pregunta. ¿Son relevantes las tácticas, técnicas y procedimientos TTPs con respecto a los objetivos de emulación? Acabamos de pensar y considerar nuestros objetivos, entonces ese adversario y sus TTPs son relevantes a esos objetivos. Relevantes también puede significar, ¿pueden tus defensores de red ¿ellos tienen la habilidad de detectar acciones por ese adversario o no? Tercera pregunta, ¿basta una variedad de TTPs para informar múltiples planes de información? Eso es crucial, porque algunas veces tenemos que empezar de nuevo. Siempre hay una posibilidad de que una herramienta rompa, el equipo de desarrollo cambie, la fecha límite se modifique, y entonces tenemos que tener bastante información para informar a múltiples planes, ¿no? Y la pregunta final, mi favorita, ¿cuáles son las características únicas del adversario? ¿Por qué nos importa ese villano? Ok, entonces, les presentamos hoy nuestro villano, Blind Eagle, también conocido como Águila Ciega, APTC-36. Y como ya mencionamos, en preparación para la charla de hoy, nosotros creamos y desarrollamos un plan de emulación, ¿no? Y entonces elegimos Blind Eagle. ¿Por qué lo elegimos? Bueno, básicamente le obligué a mi equipo que eligiera un grupo latinoamericano, ¿no? Yo tenía mis propios motivos, ¿no? Pero en realidad fue por un par de razones. Número uno, en ATT&CK Evaluations probablemente nunca emularíamos a ese grupo. Ese grupo tiene unas técnicas más sencillas, no es un grupo muy innovador, no tiene como malware customizado ni nada. No está haciendo, no está como explotando víctimas en la nube ni realizando actividades en modalidad de kernel. Sin embargo, por causa de sus acciones sencillas, es que esperaríamos que cada defensor de red pudiera detectar sus acciones maliciosas. Entonces, por eso creemos que Blind Eagle es un actor muy relevante para la industria. A ver, eso dicho, también Blind Eagle tiene unos TTPs muy interesantes y listamos algunos acá que priorizamos durante nuestra evaluación. Y las tres técnicas más importantes para nosotros eran domain fronting, process hollowing y abuso de utilidades legítimas de Windows. Y entonces, porque en algunos casos cuando le entregamos nuestro plan al equipo de desarrollo, algunas veces ellos no pueden hacer todo, ¿no? Y entonces es importante que prioricemos algunas técnicas. Es decir, si no pudiéramos emular todo, preferíamos a emular esas tres técnicas. Y también quiero decirles que hay otra charla mañana por nuestras colegas José y Santiago, y ellos también van a hablar sobre Blind Eagle. Ok. Entonces, tenemos nuestro villano, y ahora es la hora de investigarlo, ¿no? Entonces, creo que algo muy, muy única de nuestro proceso es el nivel de detalle que buscamos en reportes. Lo más detallado, lo más técnico, lo mejor. Y esas dos columnas acá en la pantalla les dan algunos ejemplos de datos específicos que a nosotros realmente nos importan cuando estamos leyendo reportes para la emulación. Y vamos a discutir algunos ejemplos específicos en las siguientes diapositivas. Perfecto. Ok. Eso es un ejemplo de un reporte de BlackBerry. El reporte analizó una campaña reciente de Blind Eagle de ese año. Y esa imagen es muy, muy detallada. Esa imagen muestra la cadena de infección de la campaña, ¿no? Y durante nuestra emulación de Blind Eagle, seguimos analizando esa gráfica porque era tan valiosa. Algunos aspectos de eso que realmente nos ayudaban muchísimo, nombres de archivos, nombres de procesos, nombres de ejecutables, privilegios de usuario, ¿no? ¿Qué hizo Blind Eagle si el usuario era administrador o no era administrador? Números de puerto y todo eso. Entonces, recuérdense que con una emulación, el propósito, nuestro objetivo es ser casi indistinguible del adversario mismo. Entonces, algunos de esos detalles posiblemente parecen más sencillos, más básicos, pero cada detalle pequeña realmente nos importa.
Another note about this is these types of diagrams very specifically show, like if you look in the upper part, they'll actually have the file names. And the reason why that's significant is because those file names change usually once they're on disk. And if you're doing artifact collection, it's helpful to know how to relate it to the network traffic that you've captured. And so for us, we had literally until we emulated it, we had no idea those 3 file names until we emulated it, and then we realized, oh, it gets changed to FiberDLL, F-Society, and async rat. And they were like, now I know what this is.
Mm-hmm. Ok, esto es otro ejemplo. De esas 2 imágenes vienen del mismo reporte, también sobre una campaña reciente de Blind Eagle. Algunas veces la información crítica sobre un adversario no está muy clara, no está ni explícitamente descrita, ¿no? Entonces hay que utilizar un cierto nivel de rigor analítico para comprender lo que hizo un villano en el entorno. Entonces, con respecto a la imagen debajo de la pantalla, el reporte estaba investigando Blind Eagle y su uso de QuasarRat. QuasarRat es como una herramienta de acceso remoto, es gratis, es público. Y como dice Blind Eagle, básicamente ellos añadieron una función especial a su uso de QuasarRat. Y básicamente esa función especial se llama activar RDP. Ahora, en el reporte nunca dice Blind Eagle utilizó RDP para, no sé, ganar acceso inicial en el entorno. Nunca dice eso explícitamente. Pero mi pregunta como analista es, ¿por qué el grupo se esforzaría a añadir esa función si no intentara usarlo, ¿no? Entonces, usaríamos eso como un ejemplo de afrontar una falta de conocimiento, una falta de información en reportes. Entonces, si Kat me acercara o otro miembro de nuestro equipo de desarrollo me acercara y me preguntara ¿cómo podemos realizar movimiento lateral en el entorno? Y si no hay más información, mi respuesta sería, bueno, parece que ellos pueden realizar RDP. Ok, entonces tenemos nuestro villano, lo investigamos, llega la hora para crear el plan. Esas 3 cosas son ejemplos de nuestros productos finales. Esos productos los entregamos al equipo de desarrollo y vamos a explicar cada uno. Ok, producto número 1 es mi favorito. Eso sirve como un diagrama técnico para nuestro equipo de desarrollo y de infraestructura también. Básicamente es un resumen de lo que está pasando en el sistema principal en cualquier momento de la emulación. Brevemente, porque como ya mencionamos, tenemos un video como mostrándote cómo iba la emulación, pero desde la izquierda a la derecha, Primero, el adversario va a ganar acceso inicial a una estación de Windows por spear phishing. Spear phishing es el TTP más favorecido de Blind Eagle, ¿no? Entonces, la víctima va a recibir un correo con un archivo PDF y cuando lo abre y hace clic en un enlace dentro del archivo, la víctima va a ser como redirigido a un sitio malicioso de donde va a descargar 3 archivos. 2 archivos DLL y el tercer archivo es async.rat, nuestro malware. Paso número 3, async.rat va a establecer comunicaciones con el servidor C2. Paso número 4, async.rat va a mantener persistencia en el sistema por carpeta de inicio. Y el paso final, acciones sobre objetivos, ¿no? Vamos a usar async.rat para ganar acceso a credenciales de navegadores web. Ok, plan de emulación, eso es producto número 2. Básicamente eso es la versión escrita del esquema de software, del producto de que acabamos de hablar, ¿no? Kat va a hablar más sobre cómo eso le sirve a su equipo de desarrollo, pero brevemente a la izquierda tenemos las etapas. Esas etapas corresponden a cada como paso crucial durante de un ataque, ¿no? Desde acceso inicial hasta acciones sobre objetivos. Segundo, atrás. Gracias. Historia del usuario. Esa columna contiene información cualitativa, ¿no? ¿Qué está pasando a nivel de usuario en cada momento? Software, infraestructura, ¿cuáles versiones del sistema operativo necesitamos para hacer todo eso, ¿no? ¿Cuáles aplicaciones necesitamos? Y final, reportes claves. Ok, producto final. Eso es ciclo vital del adversario. La utilidad de eso es para usarlo durante el ataque, ¿no? Porque el equipo rojo necesita opciones alternativas. ¿Qué pasa si ellos no pueden realizar una etapa del plan, ¿no? ¿Qué pasa si una herramienta rompe? Ellos, otra vez, necesitan opciones alternativas. Entonces, por ejemplo, si ven la caja, se dice mantener presencia, como ya explicamos, nuestra manera de establecer persistencia en la red es por carpeta de inicio. Pero si esa no funciona, el equipo rojo puede ver ese esquema y ver que, mira, el adversario también ha utilizado tareas programadas para mantener una presencia en la red. Entonces, eso sería la opción alternativa. ¿Ok? Al inglés.
English. So we just talked about choosing your villain, scoping that down to someone that you actually care about, and then building out those 3 different deliverables. So now I'll show you how we actually use those deliverables for software development. If you notice, this diagram might look a little like agile. And the reason for that is because when you take the malware out of malware development, you just have development. And that's basically a software development lifecycle, which, by the way, I don't know how they do testing, because that is probably one of the most hardest things to do when you're actually doing any type of real red dev. You're like, why didn't this work? And then you're like, oh, because there's no API calls for that in AWS, because it's a different environment, and they don't tell you about that. So props. All right. So before you even begin, what you have to do is essentially, what skills do you even need, right? So we have these amazing products from our CTI team. There's a reason why we respect the differences of disciplines. And that's because you can't expect everyone to know everything. That's not fair, it's not kind, and quite frankly, it creates a lot of burnout and resentment. And so we try to honor that, where we take those products and we use them at face value, and we trust that the CTI team has done their job. And when in doubt, ask a question. Every now, no, I'm just kidding. But they absolutely have. And so, but we have to start off with like, okay, when we get these, like that development plan from Kate, it's like, all right, well, what programming languages were used? Like, that's actually a good place to start. And the reason why is because if you're asking a developer to learn Go, Rust, Python, insert random Twitter language of the day, in addition to trying to figure out what this adversary did and recreate it and know what the instinctual, like, little intricacies of that programming language is, it's too much, especially for us. So for us, what this list really covers is like how much development time do we actually have? Not how much time do we think we can do it in, how much time do we have? For us on attack evaluations, we usually get 3 months. Now, when you're looking at nation-state actors, you're looking over years, right? You have investments and implants. Depending on what adversary you take, they've been iterating on the same implant for 8 years. And then they just changed the dropper. So as a result, you have these like very low-level experts in different platforms. And so for us, we have to decide, well, what experts do we need on the team? What platforms are we going to be actually emulating on? What languages do we need? How deep? Are we going to be in the kernel, or are we going to be in user space? For those of you that have played in these villages, when you sit down to this foreign system and you're walking through this workshop, it's really intimidating. Now imagine recreating malware from an adversary that has been doing this for years, right? It's a pretty big hurdle to get over. So we actually have to go in there with expectations that it's not going to be perfect, which is why attack is so, like MITRE ATT&CK is so powerful, is because we don't have to do everything. We just need to choose the subset. And that's really what we focus on, and that's why we lean so hard on our CTI team. So once we have all these requirements kind of down and we pulled this from CTI's product, then we go to build our team. After we do that, we take this very same emulation plan, and then we actually have a seasoned senior developer look over this. And fun fact, they don't need to look at the malware and the reporting. That's actually not where we start. We actually start at the user story. Now, the user story, this is going to be like a word description, just like Kate described, where it's like, well, what are they doing? Now, I have highlighted here about how they download a PDF from a web server, right, or a web page. Now, when you're looking at that as a malware, like, or as a red teamer, I'm like, oh, I just need to work on my PDF. But that's actually not the case, because there's actually infrastructure involved. How is that PDF going to get down? What's that traversal going to look like? Can the EDR actually detect anything? Should I actually develop anything for the EDR that it's not even going to detect anyways? And that's like a lot of these considerations that we have to factor in. And so we actually will go through here, and then we'll be like, okay, this is where we start, because this is who we need to bring into the table to have a conversation with. So I need to go talk to my infrastructure team. I don't have time to build a web server that looks really cool and fancy and like does all the cool JavaScript things to be able to profile you, fingerprint you, and then only download if you're in this certain IP range. That's a lot of work that no one actually can tell. And so I'm going to ask my infrastructure team, like, do you have the bandwidth to like set up this web server and make this all happen? Because I don't. I just need to be able to go to hit this URL and have it download and not care. And that's usually what happens at this point. Now, taking that, following along with our agile process, we use Jira. Now, you can use whatever you want. You don't have to use Jira. Use Trello. There's tons of other open source tools. Use a mind mapping tool. It's whatever works for you, because the goal of this presentation it was to be transparent with you all about our process, but it was also to give you, like, these are the core components that we have found that we cannot cut out of our process. We've had to grow because we did, like, what, like 30 vendors last round or something ridiculous?
I think it was 33.
So it was a lot. And so we've had to grow our team as a result, so the process has gotten more complicated. But if you're just like a 1-2-man team, like this entire project was actually done with just me as the technical lead and oversight. Our developer, Corey Goodspeed, so call out to him.
Shout out to Corey.
And then Kate did all of the CTI. So you're taking 3 people, like one very seasoned person that has been there and done that, one key developer, and then one CTI person. And we were able to do this whole thing within about a month and a half. So we really chose this to be able to kind of level set it down for you all, so you can reiterate this on your own and be able to pull what works for you. So we created an epic. We usually break this down by component. The reason why that's significant is because it takes about 3 months of work per component typically on a real attack evaluation. And so that's going to be your C2 handler. Like, that is a dedicated different effort. Your implant, dedicated different effort. Now, within each one of these, we have that seasoned senior developer go through and actually itemize out what actually needs to happen inside of there. That's going to be taking that emulation plan, looking at the attack techniques, and then lining those up into the actual epic, being like, these are what actually needs to be developed. And if you remember those 3 key techniques that she was talking about in the beginning, those 3 core behaviors, right? That's where this also comes into play. We have to be able to emulate those, because at the end of the day, even when we hit our dev constraints, right, everything goes wrong, the environment blows up, nothing's working. Like, those 3 things have to work. We can't not emulate them, because then we're no longer emulating Blind Eagle. We're just doing a simulation. And so that's our kind of go thing. We take that, break it into stories, and that's going to be where we'll have, like, this is the dropper. Like, if you noticed in the diagram that Kate showed, we'll always go back up to that. It's almost like coming back up for air, right? Because when you get really deep technically, you need to have a map to always navigate and figure out, I am here. And so we'll use these stories to be able to break down those different components. Like, one would be fiber DLL. The other one would be F society. The other one would be managing async rat, making sure it's all componented right. So that's how we break it down. So there is a bit of rabbit hole. I do want to call this out. For those of you that do adversary emulation or are getting into this, when you're first starting out, you just feel like you're crazy. It's a thing. But it's actually a repeatable process. Fun fact, it's not just crazy, it's a repeatable process. But it's like the process of going down a rabbit hole of research. And it's really tricky not to get lost in that rabbit hole. So I kind of captured Kat's process, and I've talked to other adversary emulation engineers on our team, and I was like, is this what you go through? And they were like, absolutely, that is exactly what I go through. And so it starts off where you have to understand a behavior, right? Before I can emulate a behavior, like process injection, I need to understand it. And there's something really powerful about hands-on keyboard. And so this is where I just understand, what is process injection? I can't be expected to know every single technique, right? There's a lot of them. There's like over 300 sub-techniques in MITRE ATT&CK. And so you take a technique, seek to understand, implement it, try it out. Then it's going back to reporting. Like, now what does reporting say about how Blind Eagle does that? Since now I have knowledge of this technique, now I can kind of like piece together how, like, why is it that Blind Eagle does this? Because if, just like in language, how there's a lot of different ways to say one word or say one phrase, right? Like, I want to say, hello, how are you? There's a lot of different ways. Why did I choose that way, right? There's a whole lot of factors that go into that. And so it's reading a report. Then it's emulating it. It's putting a procedure. And then, because nothing ever works in prod, it's like figuring out what goes wrong and then going back to reporting to try to make like reporting-based solutions and troubleshooting for that. And then, because we're having to do everything in an agnostic environment that every vendor can put their snowflake solution into that has all the hooks in all the wrong places, right places for them, we have to make it work inside of this agnostic environment, which usually makes other considerations. So sometimes you'll find when you're emulating things, it might not be perfection, and that's because it has to work. And so that adversary was building something for their specific environment. So process hollowing, we're going to use this as an example just because we wanted to make sure we gave you a concrete example. Starting with MITRE ATT&CK, it's a great place to level set. And then using those resources, you can pivot over to what does the community do? And so, like, there's a lot of different resources out there for red teamers that will literally walk you through that process. So actually putting your hands on keyboard, practicing these, like, there's plenty of resources that are out there for you. Next, it's actually going back to that reporting process, right? Still inside of that process that I just had the diagram for. Now, if I go to reporting, this specifically calls out process hollowing is done via F society DLL. It's actually called out in 2 specific reports. It's really nice when you have multiple reports calling out the same thing, right? That's collaborative reporting. And this is also what our CTI gave to us, right? So we know it's vetted. So we're going to look into this, and then we're going to notice, if you notice in the timeline, it actually calls out async rat. And we're like, okay, that's also called out in reporting. So a lot of times what we'll do is, let me go familiarize myself with code that they've obviously used, so maybe I can find some patterns in the way that they they write their code, right? Fun fact, a lot of security researchers do really wonderful coding work and provide us some great tools for pen testing. These can also be leveraged by adversaries, which is not fun, but thank you to security researchers.
Y gracias a GitHub también.
So another great resource is being able to work smarter and not harder. We don't really get the opportunity to reverse engineer. We can't expect that skill set in addition to all the development and everything else. And so we have to rely on the CTI team, but also available resources. And the fun thing about .NET is that it decompiles basically into source code. Thank you. And so we found this on Alien Vault, and we were like, well, awesome. Like, let me dig into this code. So now I have two things. I have a decompiled code that I can actually look into and understand. And I also have this open source repo of code that I know they've used. So continuing down that rabbit hole, we actually, sometimes the best way to be able to figure out patterns is Control F. And so if you just Control F some of the method names, the strings, string names, all of these things that seem very simple, you'll actually find commonalities. And in our case, we found that the same handle or the same method name was used in LimeCryptor. And when we found this, we were like, huh, it's used in LimeCryptor. So that means they're using two different projects within the same, so does that mean
Copiar, pegar.
that's game, Kate?
Y por mi parte, como analista, yo básicamente verificaría que, bueno, hace Blind Eagle eso, hace copiar y pegar desde otros repositorios públicos. Otra vez, ese adversario tiene unos TTPs más sencillos, ¿no? más básicos. Y entonces mi respuesta a Kat sería, sí, parece como ellos.
So we call this duct tape and bubblegum. And it might seem funny, but we all do it, thank you, Stack Overflow. But it's actually props, because it was really hard to take different code from different repositories and then actually make it work. And in their case, what they did was they took this method, added some functionality to it, but absolutely copy and pasted the code. So now, the difference, this is kind of where we get into the emulation versus simulation, right? The actual difference between these two. So using process hollowing, continuing that example. The way the community does process hollowing is actually quite nice. We use the ZW query information process. That gives you back this very pretty structure. You're like, I want the pointer to here. OK, now I don't care what you're running. Run my code. That's the common community method. Now, what Blind Eagle does is they do the read process memory function, which just gives you a big buffer. And then they iterate through that buffer. And then they do some pointer math. And quite frankly, I personally hate pointer math. I do not recommend it for anyone. Math is hard. But they do pointer math. And then they're like, OK, you're going to unmap this from this pointer address. And then you're going to kindly now run my code. So it's just great, because they're executing create remote thread, virtual alloc, which are some API calls that are very common for this method, that there's a lot of detection already out there on. So the community method is actually totally different than the way the way that Blind Eagle does it, which means we want to be able to detect on Blind Eagle, not the community, right? And then that's kind of part of the difference between those two. So the neat thing about emulating an adversary versus just taking Sigma rules or just basing everything off reporting is that there's something that you learn from actually writing the code. When you actually get into it and you're trying to make it work, you read that report totally differently. That report becomes almost like a roadmap that you've never read before. Every time you look at it, you find something new. And for us, when we looked at this, actually when Corey was doing this, he was like, so I got it all working, but it's 11:30 at night and it's still not installing persistence. Why is this not working? I did what the report said. He set the value to true for install for async rat, and it kept executing reg service. Now, reg service is a legitimate service on a window or Windows platform. And it was executing this because turns out Blind Eagle never actually replaced the reg service. That was never actually a part of that infection chain. And so we had one report that said something, and then we had another report that said something else. And then what we found out was when we go back to this diagram, what was actually happening was everything to that right wasn't getting executed because there was no async rat in place of reg services. What was happening was they took their VBS file that they initially delivered, popped it into the startup folder, or the link file, popped it into the startup folder, and that's an auto-run location, right? So when someone logs in, everything in your startup folder, it's naturally going to start because that's going to set the user's environment. It's a feature, it's not a bug. And so they execute that link file, and that link file actually starts over that entire process again, where it goes up, it downloads the 3 files, and it does that first part of the diagram all over again that Kate showed you earlier. And then it downloads Fiber DLL, which gets F-Society DLL, which then gets async rat and loads async rat into memory, and it starts it all over again. I think one of the reports said it was simple,
but effective.
and it was great.
Como lo básico siempre sirve.
So to kind of show you the screenshots that we have, the reason why I put them up there is you think that they don't obfuscate, you can't obfuscate .NET code, right? Because it decompiles. Well, it turns out if you put 2,000 lines of case statements, it makes a miserable reading time. And so we put this into cleaner code for you guys, which you'll find on our GitHub. Now, a big difference between attack evaluations and the community, to kind of like just to reiterate the fact that this is our process, is we, like for the community, you guys can go to VX Underground and just download the malware. You can just like, let me find this and let me run it in my environment. Don't recommend that. Or you can go to Alien Vault and like a lot of these things. But for us, we actually really have to base everything off of open source intelligence. So the reason why MITRE ATT&CK is so powerful is because it's an observation of what's already been done. It's not what can be done. It's what already has been done. And by the time reporting gets out, so we're clear, most vendors have to have like 3 instances of an incident that happened and different correlations. So that way they can report it without giving away who got infected by it. And then they have to go through all the process of publication. 9 months later, we get a report. And then however long after for the attack team to find it, we add it into attack. So there's a long delay here. So if it's in attack, it's something to pay attention to. And that's why we go to our CTI team. We're like, hey,
Hello?
is there any campaigns that they've done other than this? Because I can't do this anymore.
Y yo como analista de inteligencia buscaría más y entregársela, ¿no?
So yeah, so and the reality is if CTI says no, we don't do it. And that's kind of the way that we kind of honor everybody else. We make sure that it's always backed by CTI. So the 3 main things, the 3 main deliverables that we give, right, is going to be our source code first and foremost. But what we actually do inside of our source code is we'll usually cite the attack techniques. The reason why this is very powerful is because when you're doing a purple team operation, some of you might have experienced this where you're like, you didn't run that. And you're like, no, 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 I did. And they're like, I don't see it. So you didn't run it. And you're like, that's not my problem, right? But it also goes on the other end, right, where you're like, you absolutely ran this, I have a positive alert. And you're like, that was not where that was run. And they're like, no, it was, I have an alert. And you're like, your tool is firing on something else. And it gives you this transparent conversation where you're like, this is the line of code, right? This is what it should look like, which changes the game and it takes the ego out of it, right? And it makes it about getting to the solution, not just focusing on the problem. Another thing that we provide is the purple team operation, where we basically try to break it down to its lowest level, where we can copy and paste the commands. We built out our EC2 server, so you can literally like copy it, pop it in, run it with a Python script, and it'll execute what you expect. And we have all the techniques broken down and identified. So quite frankly, for you guys, the real benefit of this project is that you can go digging into the code. You can see what we emulated. We cite the CTI references inside of the code, in addition to inside of the documentation. So the goal is to kind of lower that bar for entry, so you guys can see where we pulled from, and then go recreate it yourself. Turn it into an atomic red team test. And I can't read the rest.
So emulation plan, yeah, you touched it all.
All right, so we've talked about picking your villains, scoping it down. We've talked about turning things into development requirements, the troubleshooting process, the rabbit hole, the research, pulling things from the community, bringing it back in, turning it into procedures, and making it into a sustainable plan, right? Now, we get a demo.
Una pequeña película. Ok. Bueno, primero, acceso inicial es a través de spear phishing. La víctima abre el archivo PDF y hace clic en un enlace. Descarga un archivo, archivo zip protegida de contraseña, pero Blind Eagle es muy amable y provee la clave. El archivo se desplaza de PDF y, bueno, revisamos la máquina del atacante y ahora ver los archivos pertinentes, ¿no? Y, mirando el código BBS en la carpeta de Windows, entonces vamos a revisar nuestro mecanismo de persistencia. Kat habló del archivo LNK y actuando como un archivo de Notepad, y todo está bien con eso. Vamos a usar async.rat para obtener las credenciales de navegador web. Y, y tenemos credenciales. Entonces, vamos a conectarnos al sitio web bancario. Dato curioso, construimos ese sitio. El adversario intenta ganar acceso de administrador a ese sitio. Entonces, entregamos el nombre de usuario y también la contraseña que acabamos de obtener del almacén. Y éxito. Y luego, tenemos que verificar la funcionalidad del keylogger, de la funcionalidad de registrador de teclas. Y está funcionando. Bueno.
Yep. Gracias.
Entonces, para terminar todo, algunas conclusiones claves. ¿Por qué ustedes vinieron hoy? ¿Qué sé yo? Pero hay unos puntos que queremos como destacar, ¿no? Uno, esa charla para nosotras era una manera de hacer transparente nuestro proceso de desarrollo para lograr una emulación. También para destacar nuestra solución para colaboración entre diferentes partes interesadas en ese proceso, ¿no? Y también es muy importante para nosotros empoderar la comunidad para crear sus propios planes. Entonces, adoptar nuestra metodología, mejorarla y utilizarla para sus propios equipos, lo que sea. También nuestro plan de Blind Eagle, todo nuestro código y recursos está disponible en nuestro repositorio de Git. Tenemos la siguiente diapositiva, tenemos un código. En todo, los códigos están seguros, no se preocupen. Pero y muchas gracias para todos y cualquier pregunta. And we finished.
Can we just get a call out that this was her first presentation in Spanish ever? It's like,
Gracias. ¿Alguna pregunta? Bueno.
English or Spanish?
Lo que sea.
toco ahí.
Lo que vos preferís.
Vamos en Spanish. Vi en algunos de los archivos que estaba mencionado F-Society. No sé si hay alguna referencia, además, a algún otro archivo relacionado con Mr. Robot.
¿Con qué?
La serie, TV series,
Ah,
Mr. Robot.
sí.
No sé si encontraron alguna similaridad. ¿Hay algún otro archivo llamado con Mr. Robot o something similar?
Yo vi el episodio de que acaba de referirse. In English, he's saying F Society, the name of the DLL file is
From Roboto?
from Mr.
Yep,
Robot.
yep, 100%. Yep.
Eso fue una coincidencia para nosotros. De hecho, F Society no es como una herramienta pública que creíamos. Y nuestro desarrollador de software estaba investigando la misma cosa que acabas de mencionar. Pero de hecho, al regresar a la pantalla en donde nosotros mostramos la imagen de BlackBerry con la cadena de infección, y esa imagen mostró que el archivo realmente que utilizó el grupo se llamaba F-Society. Entonces, por eso como mantuvimos el mismo nombre. So, like, we maintain the same name because it's the name of the artifact. Y otra vez, nuestro objetivo es ser indistinguible del adversario, entonces vamos a mantener lo mejor que podamos los nombres de archivos, los nombres de ejecutables y todo. ¿Está claro?
Sí, muchas
Ok.
gracias.
Gracias por la pregunta.
During like normal evaluations, we do reserve the right to change all the names and all the string values. Should I say that?
No.
Okay. The reason why we do that is because it's kind of a disservice to like let the string name of a file be what a vendor detects on. And so we really want to target the behaviors, not the strings. So during a real formal evaluation, we'll change all of the strings. We'll try to keep the same pattern. So for example, if it's a UUID, we'll like keep that same type of structure. But we absolutely change the string values because we don't want to create an AV test, right? We want to create an AREDR evaluation.
Hello, one question. Do you integrate your outputs work from attack evaluation with MITRE Caldera?
MITRE Caldera. So we do plugins for MITRE Caldera for every single attack evaluation. Though we don't have one for Blind Eagle or Ocean Lotus because we ran out of funding. So, and this is all open source and we're a nonprofit. So there's some limits there. But for every formal attack evaluation, we always have a Caldera port.
Muchas gracias, Kate and Kat. ¿Estáis planeando o tenéis algún tipo de roadmap donde vais a hacer exactamente lo mismo con otros threat actors en el futuro? Porque al principio creo que dijiste algo de que Blind Eagle al final, pues, es verdad que no es un actor muy avanzado y demás, y es algo que nunca vais a emular en las evaluaciones de MITRE. ¿Tenéis algún listado de actores potenciales para esto mismo que vais a hacer, pero que no vais a hacerlo para las evaluaciones de MITRE?
Like, do we have a set of standards between like adversaries that we would never emulate and adversaries that we would? Because earlier I mentioned, you know, we would never really emulate Blind Eagle. Bueno, no tenemos un criterio como formalizado en vez de, bueno, eso sí, eso no, eso sí, eso no. Es básicamente repensar en nuestros objetivos para la evaluación. Por parte de Attack Evaluations, nuestro propósito siempre es ¿qué podemos hacer que consta un reto para esos productos de ciberseguridad? ¿Qué podemos hacer en la red que pudiera como exponer esos puntos débiles o como blind spots de su lógica de detección? ¿Sabes? Entonces, para nosotros es cómo podemos constar un reto para la industria para mejorar como la configuración más básica de esos productos. Porque algunas veces esos productos que hacen el vendor siempre están al nivel más como elevada durante de nuestra emulación en comparación a lo que reciben los clientes, ¿no? Los usuarios. Y queremos explotar a ese hecho un poquito, ¿no? Para que los usuarios finales reciban, que los usuarios que están utilizando esos productos reciben una solución mejor. ¿Está claro eso?
There's a blog I have that I just published specifically on like how we selected an actor for Ocean Lotus. And so for any of you all that are interested, I know we're out of time, but we can meet you guys on the side and then I can give you that resource. So thank you all so much for coming to our talk.
Mil gracias.
Y no se vayan, que ahora seguimos con la charla de Big One.